In this video, we're going to talk about Charles's law. And Charles's law is a volume to temperature relationship. It says for a fixed amount of a gas at constant pressure, the volume of the gas is proportional to its Kelvin temperature. It's Kelvin temperature. This is saying that if one quantity increases, the other quantity must increase as well. This is a direct proportionality. So we can write that as volume over temperature in kelvins is equal to a constant, or V over T equals K. So if the temperature in kelvins of the cylinder is doubled here in this picture, then the volume of the gas doubles. So here we go from 200 Kelvin to 400 Kelvin. Now, a 200 Kelvin to 400 Kelvin is actually quite a large increase in temperature. That's a 200 degree C increase. Because remember, a degree C, the size of the degree C is equal to the size of the Kelvin. And a 200 degree increase is quite significant. Now, we can write this much as we did the Boyle's law. If we have our starting conditions and our final conditions, we can write V1 over T1 is equal to V2 over T2. So let's try this out. A 2.5 liter balloon filled with air at 12 degrees C is taken inside a warm house whose temperature is 24 degrees C. What will the final volume of the balloon be? Now, you might think, oh, I doubled the temperature. Therefore, the volume must be doubled. But remember, this has to be in kelvins. So, first thing we need to do is let's list out what we know. So, my initial volume, V1, is equal to the 2.5 liters. And the temperature at which that 2.5, T1, is equal to 12 degrees C. Now, our volume 2, we don't know. That's our question mark. And our temperature 2, that is, when we take it inside the warm house, that's 24 degrees C. Now, I can't use degree C. The reason that I can't use degree C is, what if I have 0 degrees C? Since our equation is V1 over T1, if T1 were 0 degrees C, you'd be dividing by 0. That's impossible. You can't do that. So the temperatures must be in kelvins. So remember, to change from temperatures in degree C to Kelvin, temperatures in Kelvin are equal to the temperature in degree C plus 273. So let's take a look at our variables after we do our conversion. So once I've listed these out in terms of Kelvin, I can see that I've got 2.5 liters at 285 Kelvin, and then the volume 2 I don't know, at 297 Kelvin. Now our equation is V1 over T1 is equal to V2 over T2. So I want to find V2, so I'm going to multiply both sides by T2. Remember, just like I said in the Boyle's Law video, rearrange your equation before plugging things in. So T2 cancels out. I get T2 V1 over T1 is equal to V2. Plugging in my numbers, 297 Kelvin times the 2.5 liters over the 285 Kelvin, I see that the new volume is 2.6 liters. That's not a very big increase, but that's okay because I didn't have a very big increase in my temperature in kelvins. So I'm not expecting a doubling because I didn't double my Kelvin temperature. I only increased it by 12 kelvins. So my volume shouldn't increase a whole lot. Now we can use Charles's law to actually explain weather phenomenon. As warm air, as the temperature of the air goes up, warm air starts to rise because it becomes less dense. It has higher volume. Higher volume with the same amount of mass means less dense. So it goes up, and then what happens is cooler air at the sea moves in to take the place of the warmer air. So that is why it is one of the reasons why it's a a tempering effect to live next to the ocean. The cool air from across the water comes across the land as the air heats up in the summertime. So, this was an introduction to Charles's Law. I suggest you do as many problems as you can on Charles's Law. And again, make sure you rearrange your equations prior to plugging in your numbers. You will definitely increase the speed at which you can do these problems, and it also helps when you error check. Move on to the next video, in which we will discuss a pressure to temperature relationship.